Let's continue from question 11. It says which role is correct for asexual reproduction? Okay, asexual reproduction does not involve reproduction. That does not involve. Don't use contractions. You are expand. That does not involve gametes. Gametes are simply sex cells. Okay, sex cells. It means there is no fertilization involved. So, for example, there is budding. Budding is it's a form of asexual reproduction. So, whenever we would have asexual reproduction, the offspring, they're genetically identical to the parent. Okay, and then the parent is also singular. So, single parent, genetically identical. Offspring. Okay, so it means the parent and the offspring, they are genetically identical. They're exactly the same. So we're going with A. Let's quickly move to the next question. So question 12, which organisms? So this is a food web. So it's a food chain would be only one part. Okay, it'd be head, tail, like this, and then you wouldn't be having any other branches. Okay, but then in your food web, this would look like a web. So you have so many interconnectivity there in the ecosystem. So here is what you need to know. They're asking which organism in the food chain, which organisms in the food chain are secondary consumers. These plants, they're called producers. The reason they're called producers is that they photosynthesize. Okay, it means that they are the ones that have the capability of making organic matter, so organic matter in the sense of glucose, and they also produce oxygen as well. But in this case, we are talking about glucose, and they make that from inorganic matter, from carbon dioxide and water and sunlight, which other animals here that they won't be able to make. These are called producers for that reason. They produce everything that's competed away in the food web. Okay. These ones, they're called primary consumers. So primary consumers, they are all herbivores. Okay, they are all herbivores. So it means that they feed primarily on plants, only that. So they are herbivores, primary consumers. And the next, what we get in the next one, they're called secondary consumers. Okay, so you have one here, then you have two. So obviously this is a secondary consumer. You have one here, then you have two. These are secondary consumer. You have one here, and then you have two. These are secondary consumers. Now just the other ones, the next part is called tertiary consumers. Okay, but then let's not go there. We are just asked to identify the secondary consumers. So we have carnivorous insects here, but then voles they included, of which voles they are primary consumers. Okay, so we are going to decide against this one. Frogs and lizards, they're up there. Then kestrels and storts. Storts definitely, kestrels definitely. So it would be this one, this answer. And then spiders and storts. So spiders here, they are not secondary consumers, they are tertiary consumers. So yeah, that's it. You choose kestrels and storts. So let's quickly move to the next part. The next part says which process in the carbon cycle releases carbon back into the atmosphere. Okay, so carbon into the atmosphere. This qualifiers, they're very important. Sometimes they ask you carbon into the carbon sink, as in carbon from the atmosphere. This one they are saying into the atmosphere. So we're looking at this process here, respiration. Why? Because you have glucose plus oxygen, then you get carbon dioxide plus water. So respiration, it's obviously contributes to carbon back into the atmosphere in the form of carbon dioxide. Okay, and this is not the only process. We also have combustion of in industrial activities. So, for example, in power generation, we have combustion. So combustion, there'll be carbon dioxide there. So this carbon dioxide also, it contributes immensely to carbon being in the atmosphere. Okay, so we're going to choose respiration here, but then just know that industrial activity, they're also very contributory to carbon dioxide or to carbon into the atmosphere. So question 14 says, which method of separation depend on substances in the mixture having different boiling points? Okay, so you're dealing with a mixture here. A mixture, it simply means that the constituents, they are not chemically bonded. So for example, you can have salt and water. They don't react in any way. Salt just dissolves in water. I'm talking about table salt. Table salt is called sodium chloride. Okay, so that's it. So we're talking about mixtures here. When separating mixtures, one of the crucial differences is that you separate them by physical processes. Okay, so we are dealing with physical processes of separation. So the what physical process here depends on boiling point. It will be fractional distillation and distillation. So it'll be this one here. Paper chromatography, we rely on the rate at which the colors climb up maybe some paper. It'll be different. So that's how we isolate the dyes or the substances that are of different colors. There's this one, chroma. It simply means something to do with light. Okay, so this procedure here, it hinges a lot on color. Okay, light, it's something that we associate with color a lot. If you see a rainbow, that's white light being undergoing some sort of refraction, and then you'd see now the components of white. White, it's not a primary color. The primary colors are all the other colors, and if you combine them, they form white. Okay, so that's it. Let's quickly move to the next question. Which row describes an element and a compound? So an element, the stuff that you see on the periodic table, those are elements. Everything, the stuff that you see, maybe copper, silver, fluorine, chlorine, all those, they're elements. The stuff that you see on a periodic table, they're called elements. And the thing about elements is that they contain only one type of atom. Okay, we usually identify this type by the what's called the atomic number or proton number. Okay, so a compound now, it contains elements chemically bonded together. This is very important. Okay, you know, when you're dealing with compounds, you're now dealing with physical chemistry. So there is either transfer or there is sharing of electrons. It's just there, but then it's not a physical mixture. That's why, what you actually separate a compound, you have to do you have to do it by chemical means, or even electrolysis. But then generally we do it by chemical means because they're chemically bonded together. Let's quickly move to the next part. And then here, just remember, so that now you have a functional difference about elements and compounds. You can even repurpose the same to define some of these terms. If you're asked to explain an element, what it is, so if as opposed to a compound, these are some of things that you could know from this question. Okay, let's quickly move to question 16. The apparatus shown is okay. The apparatus shown is set up. So we have this apparatus here. Okay, and then you're asked. So this is an electrolysis setup. So electrolysis setup. So electrodes. These are the code. They are the anode and cathode. Okay, these are just electrodes. You have this lamp here, and this solution or this part here, it's supposed to connect to create a conductor here, such that there will be, if this one is a conductor, if lead, bromide, it's a conductor in whatever state that we want it to be in. That means that we'll see the light glow. Okay, so you can be asked, if this is solid lead bromide, what happens to the lamp? It doesn't glow. Why? Because it doesn't conduct electricity until it's molten. So here it says the crucible. The crucible would be this, you know, and then it needs to be heated. So the crucible would be this, and then it needs to be heated for the lamp to give out light. Why is heat needed? Okay, so initially, again, when this is a solid, you don't register any light here. We say that this doesn't conduct any electricity. Why? Because the electrons, they are no free electrons in lead bromide. Okay, so the electrons, they are no there are no free electrons, of which you need free electrons to actually, transmit current. So here you may be asked, why is this conductive? It's not conductive. Why? Because electrons are locked up. There are no free electrons. And then why is heat needed now? We need the heat so that the lead bromide must be molten. Okay, so the lead bromide, it must be molten, and when it melts, now you now have free electrons, and these electrons obviously they can conduct, and thereby you have light here. So let's quickly move to the next part. Okay, let's analyze some of those options as well. So an exothermic reaction takes place in the crucible. So this is not necessarily the case. Exothermic reaction, by the way, it's a reaction that releases energy. So when you're actually heating this crucible, it's somewhat a process that takes in um, energy, okay, as opposed to releasing energy. But reactions, basically, we usually classify them as exothermic or endothermic if there is actually a chemical change. Okay, so when you are just melting this, there's no chemical change, so this is redundant, it's unnecessary. And electrodes only conduct electricity when hot. This is not true. So, for example, the electric wires that you have, they conduct electricity and at any temperature really, and without any air. So you can also think the same of electrodes. So heat causes lead bromide to react with air. This is not the case. Okay, so let's quickly move. Our answer is D. Question 710, it says, which word is used to describe a reaction that takes in heat? Okay, that takes in heat energy from the surroundings. So that type of reaction is called an endothermic reaction. Endo means it's going inside. Exo means you're now taking out. If they had said that takes out heat from the so from the that takes out heat from the reaction, so that gives out heat, that releases it, then you'd be looking at exothermic. Then oxidation can be defined in many ways. So it can be addition of oxygen. Okay, it can be loss of hydrogen. Okay, it can be loss of electrons. So these are the number of ways that you can define oxidation. For reduction, be this the difference, so the reverse. So a loss in oxygen, a gain in hydrogen, a gain in electrons. Those are called reduction processes. And reduction processes, you're likely to find them when you're extracting certain metal elements from ore. So for example, when you're extracting iron, that reaction that produces iron, it's actually a reduction reaction. Okay, let's quickly move to the next part. Question 18. Question 18 says, 4 separate samples of magnesium are reacted with dilute hydrochloric acid. In each reaction, the concentration of hydrochloric acid is the same. Which experiments gives the highest rate of reaction? Okay, so you asked to predict which one would give the highest rate of reaction. So the item which would, the option which would give the highest rate of reaction, it's supposed to be, let's analyze it. Let's for temperature. So we expect the temperature to be high. Okay, so why? Because there's a principle. You probably know how to pronounce this better than me, but I say Le Chatelier's principle. So it explains some of those effects. But then there's also the collision theory. It also explains how the speed of reaction is affected by temperature. Okay, so if you increase the temperature, you're increasing the number of collisions that are happening there. And the number of collisions, if you increase the frequency of collision, you're also increasing the number of successful collisions. And any successful collisions, they count to the reaction proceeding. Okay, so here we are deciding against this because they have lower temperature. And then here, so we have magnesium reborn in this much of dilute hydrochloric acid. Okay, so this one it's more than this, so this reaction is likely to take longer. Okay, so the reaction rate, which would be faster, it's actually this with the little volume, low amount of volume. Okay, so we'd actually choose A. So this with the little volume, it would proceed rapidly. Okay, let's quickly move to the next question, question number 19. So which reaction represents a reaction in which oxidation and reduction occurs? So this type of reaction is called redox. Redox simply means re for reduction, read for reduction, and then ox for oxidation. So in order to investigate reduction in oxidation, if you're doing chemistry, you have to track the oxidation numbers. Okay, so for example, for calcium it would be +2, for carbon it would be +4, and then for oxygen it would be -2, but then there are actually 3 of them, so you have -6, -6 +4, then you get -2, -2 +2, then you get 0. So you can actually see that there is a sense in which this balances and then gives the overall reaction, the overall charge. Okay, so here it will also be +2, -2, again you get 0 here, and then here it will be +4, -2. There are 2 of this, so obviously it will balance out. And what you notice is that there is no change in oxidation numbers. So calcium it's still +2, carbon it's still +4. But then if you're having a hard time now understanding some of these things, here is how you can predict which one would be a redox reaction. This reaction here, it's called a double displacement reaction. So what's happening is that this part here, it's combining with this part, and then this part here, it's combining with this part. So we call this a double displacement reaction. So a double displacement reaction or double displacement reaction, they are not redox. So you still have sodium, you still have sodium is an ion. Nothing has changed about its oxidation state. And what's happening here is that they just changed the dancing partners. Sodium was dancing with carbonate, zinc was dancing with sulfate, the sulfate ion, and then now sodium is dancing with the sulfate ion, and zinc is now dancing with the carbonate ion. So they just changed partners. That's it, nothing else. So this one we say that the oxidation state doesn't change. It's also the same with this one. You can also view it as a double displacement reaction, although this one it's actually a neutralization reaction. Okay, a neutralization reaction, acid and a base forming a salt and water. It's also a double displacement reaction. Okay, so neutralization reaction, okay, it's also a double displacement reaction, so we are going to decide against this. So we said we are going to decide against this. This one we say that was a bit tricky, but here see, this one would be 0 because it's a molecule. This one would be 0 again because it's a molecule, and then when they combine now, you actually have hydrogen is +1 here, oxygen is -2 here. So the answer would be B. Okay. So the answer would be B. So final question for this video. A mixture of ammonium carbonate and ammonium chloride is heated with aqueous sodium hydroxide. Which gas is produced? Okay, so you're dealing with ammonium and ammonium. So, and then it's reacting with this strong base here. So the gas which is produced, you can read even from here that the gas which is produced, it's actually ammonia. So the gas which is produced, it's ammonia. This one I didn't explain why this is so, but I want you to go and research why is it we don't release carbonate. For carbonate, normally we would have released maybe carbon dioxide. For chloride, maybe we would have released chlorine. And why is it that still they are not evolved? Okay, just go look it up. But normally, when you have an ammonium reacting with a base, strong base, you produce ammonia. Okay, that's the gas that's evolved. So yeah, that's it for this question. Make sure you like, share, and subscribe. I'll catch you in the next video. Thanks for watching. Cheers.